All right, now we're going to talk about groundwater pollution. So it's not visible because, well, it's under the ground. And so you have to drill into the aquifer and collect samples to test for it. And so because of that, there can be a long time between like the source of the pollution and where it's detected, because it's not like we just go around drilling and testing water in random places. So it usually shows up like in a bad spot at a bad time. Groundwater pollution in karst areas, like here in Kentucky, can spread very quickly because it's not, trickling through these very small pathways in very microscopic pores in rock. They're traveling through caves, which are pretty much just an open air system. You can travel through some of these caves and voids in karst as quickly as you can, just a normal river. Here's just a map, again, looking at nitrate. So this is what has soaked into the groundwater and where that's a problem. Matches very closely to the map we saw of nitrate concentration and application rates in farmland. Um, and then here's just showing that it's a more concentrated and shallow water depths. And as you go deeper, you find less of it, which is kind of common sense. This kind of reinforces that here. If you have aquitards, which are these impermeable zones, it's not completely 100% impermeable, but like pretty much it's impermeable as far as we're concerned. Um, it really, 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 really slows down the flow of rock. And so the more impermeable layers you have between the contamination source and that aquifer, it's going to take a lot longer for that deeper aquifer to go in it before it's contaminated, saying, centuries to thousands of years. This one up here, which is not confined, years to decades. I mean, just however long it takes for something that like is spilled right here just to soak into the ground. Tracing pollution's pathways. We have these contaminant plumes, and so here's like a cross section of a contaminant plume right here. And so here's the pollution source. This is a landfill. And so the water is flowing this way. And so it's going to be mostly concentrated underneath. But then as the water continues to flow, it's going to go downstream, which is usually downhill. Um, from that source. And so here's what some of that real data looks like. So if you were to just drill around here to test, you would see these different concentrations. And then if you imagine a map view, to the left or right, um, you'd kind of have this circular plume as well. And so they'll do that. They drill, they'll test, they'll figure out how far downstream, how laterally the contamination is, and then they'll try to treat it depending on, well, what you're working with and how large the contamination is. And if you don't know where the source is, let's say you like you're build a house and you're like, I want a well water put in, I drill and it's contaminated, then you have to kind of go backwards and drill around and then like find those higher concentration rates if possible to see if you can find a source. You got to know the rate at which the water is flowing through the aquifer and everything too, to know how fast it's going to spread and how far. Um, so how do you treat it if it's under the ground? There are a few ways. You can pump it out and treat it, and then either just, if you're before you drink it, treat it before you drink it, or pump and treat it and then put it back down into the ground. You can either treat it with air or charcoal, and there are probably other methods too that aren't listed here. Here's an in situ way of treating in which they put in this permeable reactive barrier. Um, so this is iron. So they're using iron to kind of clean it. So like if the groundwater is coming in here, they're forcing it. They put this impermeable zone in here, and then they're trying to force it like right through here where they've put this iron wall to interact with the contamination so that as it comes out the other side, it's been treated. You can also do the same thing, which is putting like an impermeable zone in the pump and treat, and then like treat it and then put it back on the other side of the downstream. And so here is an example. Here is the data from here. So this is the groundwater contamination before entering this iron wall and then exiting the iron wall. Oh, and then here's what I talked about. Like, so we put in this clay rich, so this impermeable zone right here. Let's see, groundwater is moving this way, so pump it out, treat it, and then instead of just using it here, putting it back into the ground on the other side, nice and clean. And that is it for water pollution.